All right, well, welcome to the first of a series of OnShape tutorials going over what you can actually do with a free OnShape account. So I've been using OnShape now for about 6 years. I use it every day as part of my profession. And what we're going to be going over today is sort of how to make this geometric Art Deco style vase or planter. Um, and it looks quite complicated, but it can be done in under 40 features on the feature tree. So what we're going to do is we're going to start a new part studio so that we just walk through this together from scratch, and we will start a sketch on the front plane. So what I did there was I hit N to bring it normal into view. I'll probably be using a few keyboard shortcuts that I might not say at the time of using them, but I'll try. And what we're going to do is we're just going to create a very simple sort of sketch that's going to drive the entire geometry of the perimeter. So what we'll do here is we'll say that is, I've already messed up saying when I'm going to use these keyboard shortcuts. So D is a dimension. You can find it up here. I'll click it on that point and the center line, drag it over the center line to have a diameter, and drag it in the center line to have a radius. If we're going to be revolving this later on, it's nice to have the diameter. So I'm going to set this as 200. I'm going to set the base as 150. These are just arbitrary for now. I'm going to set this as 150 as well. And then in order to fully constrain this, so the blue line means that sketch line is unconstrained. It can move around. We basically haven't told it what we want it to be yet. So I'm just going to dimension that as 30 to the center line as well. All right. And so what we want to do now is we want to start thinking through how we're going to bake in these configurable variables. So what I've done here is we've made a few dimensions here that we probably want to be able to change later on. And I'm thinking right off the bat, we're going to want to change the diameter of the opening of this little pot thing, and probably the height too, if we want to, work through a few different variations and quickly decide on a look and shape that we like before we, 3D print it or cast it or something like that. So I'll go over to the configuration panel over here, and I'm going to say, let's configure this part studio. Add a configuration variable, and we're going to call this height. The default that I just set it to in the drawing there was 150, and we can say, we probably want this thing to be within the range of 50 to 500 millimeters. We're just giving it some rough constraints there so we don't have to think through every single possible dimension that it could be. Height, let's say diameter as well. So the diameter I just sent there was 200, and let's say that we want a minimum of 100, maximum of 500. These are just arbitrary. I'm just picking them based on what I'm imagining this thing will end up being. Okay, so we have height and diameter. So let's go back in here and we'll set this to diameter. So now if we change this value up here in the configuration tree, it's going to drive a change into this sketch here. If I change this to height, the same thing will happen. So you can see it here. If I change this to 175, that's going to change to 175. If I change this to 250, that's going to change to 250. So we'll keep it at 150 and 200 for now, and we will proceed with the rest of the drawing. So the next one we want to include is the number of repetitions around this central axis that we want to create. Because what we're going to be doing is we're going to be drawing a single repeat of this pattern and then creating a circular pattern around that axis so we don't have to draw every single one. So we'll add a configuration variable. We'll say number of repeats. Not very scientific, but gets the idea across. as an integer, not a dimension, because we're calling it into an equation that is dimensionless. So we'll say 20, and we will say here minimum was 10, maximum is 30. Okay, and so now when we do that revolve, axis, we want symmetric, 360 degrees of the full circle divided by number of repeats times 2. There we go. So we have our slice here. And then this is going to become the basis of what we sort of project that pattern onto. I'll show you what I mean by that now. And now what we want to do is we want to create the pattern that we're going to use to drive the entire sort of face geometry here. And it's pretty simple to do. So what we'll do is we'll select the right plane, hit N to bring us normal to it, we'll sketch upon it. We can use U here to project these edges onto our sketch plane. And what that means is that it's bringing in these actual edges onto the sketch. So if these edges change their position, these sketch entities will also update. We will highlight them, and we will hit Q up here to convert them into construction geometry. And what we'll do now is we will draw lines, so L, down the center, and we'll draw 6 lines. 1, 2, 3, 4, 5, 6. And what these are going to do is they're going to sort of operate as the center lines of these sort of facets here. So every point there that we've just drawn is going to be a center line of this. And what we'll do is we will set them all equal to one another. So highlight them all and hit E. You can also do it up here by selecting equal. Again, what that means is that if we change this dimension, which we've added a variable to be able to change it pretty quickly, all of these lines will change their dimensions as well. They're going to sort of shift to remain equal with one another. Highlight that, hit Q. All right, what we're going to do here is we're going to draw sort of the basis of that shape. And what we want to highlight this and say, I want to be horizontal with this point, but create a vertical line. Another line here, Q, to make construction geometry. And what we can do now is we can just mirror this all the way down. So we can select mirror up here, select the mirror line, mirror all those. Draw another mirror line at this point, mirror the ones we just mirrored. And we'll do that all the way down. Mirror line, mirror the ones we just mirrored. Another mirror line, mirror the ones we just mirrored. I'm doing this on a trackpad MacBook, so it's a little slow, but we'll get there. All right, so now we have this pattern that's completely mirrored all the way down. It's based only on these 3 lines. All of these are the exact same, just mirrored about each center point of this sort of main construction geometry that we've drawn to base the entire sketch off of. And right off the bat, we can see that it's not defined yet, so we've got to start adding some dimensions in. So we will dimension this as 5, we'll dimension this as 3, and I'll set this height here as 5 as well. And I'll set this height from that point, and again, I'm hitting D every time I do this. From that point to here, we'll say that that's 15. These dimensions, I don't know if we're going to want to change too much, but these dimensions, I think we will. And I'm just kind of thinking through what implications these dimensions are going to have on the actual design of this thing in the end. So what we'll do is we'll exit out of the sketch for now, and we will add 2 configuration variables. We will call this one edge gap 1. I set it as 5. We'll say it needs to be at least 1, can't be more than 6. We'll call this one edge gap 2, and I set it as 3. We'll say we don't want it to be less than 2, and you know, we probably don't want it to be more than 5. Just guesses at the moment. Okay, so now we've got this sketch, and right now it's kind of jagged, it's kind of sharp edges. If we just start surfacing based off this, it's not going to look very good. So what we'll do is we will go in and add some sketch fillets. Again, I'm going to be doing this on a trackpad, so it's not going to be very clean. Okay, so what I've done there is I've accidentally clicked between selections. What you want to do is you want to select them all at the same time so that, oh god, done it again. All right, there we go. Gotta be very careful here. Very careful not to click outside. Just so it's only creating one dimension for every single fillet. We'll give that a radius of 6 millimeters. That looks good. If you click and then click and then click, it's going to create a dimension for every single one of these, and you're going to have to edit them all independently, and you know, we don't want to be doing that. Okay, so we've got our main sketch that's driving the geometry of that pattern on the outside. What we're going to do now is we're going to create another sketch on the right plane. We could do this all in the same sketch, but I think it's cleaner to keep them separate. We're going to offset this entire chain 0.5 millimeter one way, 0.5 millimeter the other way. And what you can do is to select the whole thing very quickly. We'll do tangent connected. So right click on the line, do that again. We'll select offset or O, right click, select tangent connected edges. And it's going to offset that entire chain. What we want to do is we want to give that a dimension of 0.5. And now here is something you got to keep a keen eye out for. When you offset, oftentimes if it's not a closed loop, it keeps the end points undefined, so they're not constrained. We want to constrain that to the top. We want to constrain this to the bottom, and we want to constrain each of these to the midline. So what I'm doing here is I'm selecting it, hovering, and snapping it to that midsection. What you don't want to do is you don't want to hover and select over this point, because that's going to undo the offset. So you want to hover over the line. And here what I'm doing is hovering over the point and then dragging to the left so that it's putting it in a horizontal constraint. Okay, that's one. We want to do the same thing in the other direction. Again, offset, select, tangent connected edges, click the arrow to flip direction, 0.5, and again we've got to make sure that these are snapped, because if we start changing stuff later on with the configuration variables and we have unconstrained sketches, it's a bad time. You're going to start breaking all the stuff in the feature tree, and you're going to be scratching your head trying to chase down all the errors. Okay, now we've got this nice offset looking loop here, and what we're going to do now is we're going to project these edges onto this slice that we created earlier. So one way to do that is by extruding surfaces. So we'll go up, extrude, select surface, right click, select tangent connected edges, right click, select tangent connected edges. And let's give this something ridiculous, like a meter, so we don't worry about, you know, if we start changing the diameter of this with our configuration variable, you know, if we're only extruding it to this point and we change the diameter of this and we move it past the point this is extruding to, it's going to start breaking the feature tree. So now we've got these three surfaces that are intersecting, or two surfaces that are intersecting with our main surface here. So what we want to do now is we want to go mutual trim. And what this is going to do is going to trim these surfaces with our main surface. So basically all we want is this little middle surface here. And we want to trim everything else away. So we'll select first surface, second surface. You can see here, we don't want to do this because it's going to get rid of that section that we want to retain. So we want to keep that middle section. We'll hit OK, and then we'll mutual trim again off this surface and this surface. And there we go. So we have all this extra stuff here that we want to get rid of. So let's go up here. We'll hit delete face. That's right there, sorry. Right click, select tangent connected faces. Right click, select tangent connected faces. Didn't. There we go. Okay. So we've got this surface that is now in our nice little geometric shape. What I've done here though is I've mutual trimmed that before establishing reference planes that we're going to need later on for some mirroring operations. So let's add a plane here. This is going to be a reference plane that we're going to use to mirror the patterns based off of. So I've selected 3 point because I want to select 3 points along this edge. That's plane 1. And plane 2, we'll select 3 points along the other edge. One, 2, 3. And so now we've got these planes that are sort of orthogonal to the tangent of this edge. Basically, this whole edge is contained within the plane. It's our slice plane. All right. So we can go back here and we'll drag the feature tree back to where we left off. We have our surface here, and we want to start building up the actual pattern that we're going to use to create the rest of this container. So what we're going to do is we're going to take this surface and we're going to apply a ruled surface to both of these edges. So select tangent connected edges, flip the direction, we'll set that equal to 5, and make sure you select new, not add, because we want it to be a new surface. And what that's going to do is it's going to take a surface and sort of extrude it out from the normal of every single point along this curve. And that'll be important for the loft feature that we're going to be doing in a second. So we'll bring back the initial surface, and we'll add a ruled surface to the other edge. So same exact thing on the other edge, tangent connected edges, 5 millimeters, flip it around, new. Okay. So now we've got these 3 surfaces that we're going to use to build up the actual repeating pattern. Okay. So what we're going to do is we're going to mirror all 3 surfaces about one of the slice planes that we made earlier. And then we're going to mirror all 3 of those same surfaces about the other slice plane. So now there we go. Things are starting to come together here. All right. We got to make sure that we are hiding these 3 surfaces because we only want the ruled surfaces showing from here on out. For now. Okay, so what we're going to do is we're going to create a composite curve. And what this is going to do is it's going to take all of these individual sections and turn them into one selection. So when we're doing the loft operation, we only have to make that single curve selection. So on this inner ruled surface, let's do select tangent connected edges, and that's one of our composite curves. We'll go over here, select tangent connected edges. That's another one of our composite curves. And then in this inner edge, select tangent connected edges. That's the third of our composite curves. And then the fourth is this inner one as well. Select tangent connected edges. So now we've got 4 composite curves that we're going to be using for the loft feature now. Okay, loft. Profiles. We're going to select the first composite curve. We're going to select the second composite curve. And that's going to create a surface in between those 2 curves, which is fine in and of itself, but we can add a little bit more depth to it here by saying we want it to start by matching the tangent of all of these faces on the ruled surface. And we want to do the same on the end profile. Select tangent connected faces. And what we can do now is we can vary the amount that it's going to be tangent to those surfaces on. Oh, -10, we want +10. Okay, so we want that to be 10, not -10. All right, and so now we've got one of our surfaces on the inside. Now we just need to make the other one. So we're going to do the same thing, loft. This time we're going to go from our third composite curve to the fourth composite curve. And I'm selecting it down here in the curves tree. Again, we want to match tangent on the start and end. Adjacent faces on the start are all of these faces. Adjacent faces on the end condition are all of these faces. And we'll add 10 and 10 again. That might be too much on that one. Let's do 5 and 5, just so they're somewhat equal to one another in depth. Maybe 3 and 3. Okay. All right, now we can hide all of our ruled surfaces. We don't need them anymore. We need to bring back in our edge surfaces. And then what we're going to do is combine all of these together. So we're going to combine this and turn them all into one surface. Just like that. All right. And now what we want to do is we want to draw on the front plane, so N to bring us normal, sketch. We want to use the lowest point here to trim to. What might be better is to just draw a line across. So what we'll do is we're just going to trim off the excess on the top and bottom, so we have a flat face. We'll give that 5. We'll do 5 at the top as well. And I'm referencing, again, the main sketch because that's what's referencing the slice that we generated earlier. Okay, and now what we'll do is we'll add a reference plane to each of those lines. So come over 3-point, line angle. We'll select that top line. We'll offset the plane by 90 degrees so it is flat. We'll come back, line angle, do the bottom one. Again, 90 degrees, not 9, we want 90. Okay, and now we're going to split this entire surface with the top plane. We don't want to keep both sides because we want to get rid of the part that we're trimming off. So we'll move that around because we want to keep our large side, and we'll split this surface again with the bottom plane. And again, we don't want to keep both sides. We'll just check that we're keeping the right side. We don't want to keep that side. We want to keep that side. All right, now we've got our flat planes. And we've got a pattern that is ready to be circular patterned around that axis. So what we're going to do here now is we're going to circular pattern this surface about the center axis. We are going to pattern it number of repeats. So the number of times it's patterned is the number of repeats. There we go. And what it's done here is it's actually generated a new surface for each pattern. We don't want to do that. We want to add it to the original surface. And it's probably going to start complaining and slowing down a bit as we start doing these larger patterns on the complex surfaces. Okay, so we wanted to add all of those surfaces it's creating to the original surface. So we'll say merge scope here. We'll select surface 8. And it's going to go through and do that. There we go. So now we have one continuous surface. All right, now we need to close this thing up so that we can shell it and have it, be an actual container that we can print and use. So to do that, what we're going to do is come over here, fill. We're going to select these edges, select equal length, select equal length, and select equal length. And then what that's going to do is it's going to fill in this entire perimeter with a flat surface that joins all points along all the edges that we've selected. Just like that. And it's still just a surface because the bottom is still open. So once we close off this bottom, OnShape is automatically going to convert it into a solid part. So what we'll do here, select equal length, select equal length, select equal length. And again, it's going to go through. And fill it up. You can see now it's no longer a surface, but it's an actual solid part. All right. Okay, so now what we want to do is we want to hollow this thing out. So we'll come over to the right, the front plane. We'll hit N so that we're normal to it, and we will sketch. So what we can do is we can actually come back and refer to the original sketch that we made, and we can offset this. So we hit O. We can say we want the wall to be, 7 millimeters thick. We want the base to be probably pretty thick as well. We'll say 7 millimeters too. So I'm going to dimension that line, pressing D, dimension that line to the bottom, and 7. Okay. And now what we can do as well is we can kind of take a chamfer off of this surface to just give it a nice little finishing touch. Sorry, we'll select that, select the top face, press I to make it coincident. And what we will do is we'll connect that to this point down here. Okay, so now we've got a solid shape. do now is we'll take a 45-degree angle line and chamfer this top edge, and we'll just revolve it all at the same time so we don't have to worry about doing multiple features. We'll just give this a nice large length so it's always over that edge. Alright, we will hit revolve. We want to do a solid revolve because we're going to be using it in essentially a Boolean operation. We want to remove, what faces do we want to remove? We want to remove this face and this face. And we want to revolve it around the central axis. It's going to think, it's chugging along, trying its hardest, and there we go. So it's merged the scope of the remove with the part that we want to remove it from. So that's good. And there we go. We now have a nice planter object. Maybe what we'll do here is we'll add some fillets on the top edge so it's not that sharp entrance. And so what we can do is we can, maybe we want to change some of the stuff now that we have seen it in its final form. We want to make it a little bit taller. So what we can do here is we can roll back. And we'll change the height of this thing. We'll say we want to make it 300. So now we've got this crazy looking thing, but it could be a nice little lamp hanging from the ceiling or something. Cover for another object. I'm going to take it back down to 150. And let's say we want to change the number of repetitions, say down to 15 instead of 20, to see what kind of pattern that gives us. There you have it. And that is a pretty in-depth OnShape surfacing project. And I hope you were able to follow along and were able to try it out and maybe even print out a few cool looking parts. Take care.